Hello, and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we'll continue our exploration of the derivatives of trigonometric functions. So let's jump right in. So since we already know, Since we already know how to find the derivative of the common trigonometric functions, and we can simply apply chain rule, power rule, quotient rule to that, we can already get the gradient of the tangent on a trigonometric graph. There's not much else to be said, so let's jump right into some questions. And I'll do the odd ones. So first, we need to use product and quotient rules to differentiate with respect to x. So first, we have y is equal to sine times 2x plus 1. And we need to differentiate this. So again, we have we differentiate the inside and multiply to the differentiation on the outside. The derivative, sorry. So u is equal to sine 2x plus 1. So we have cosine u times 2. So we have 2 cosine u, which is equal to 2 cosine 2x plus 1 as the answer. So that was a pretty simple first one. Next, we have y is equal to cosine of x divided by x. Okay, so we can use quotient rule for this. So we have vu prime minus uv prime over v squared. So v times u prime is negative x sine x. Since the derivative of cosine x is negative sine x, minus uv prime, which is minus cosine x, over v squared. So this is negative x sine x minus cosine x over x squared. So yeah, that was it. And on to the next one. We have y is equal to tan x over the square root of 2 minus x. So similarly, we can use quotient rule. So we have v times d over dx. So we have secant squared x times the square root of 2 minus x minus tan x times the derivative of this, which is more helpful to write as to the power of 1/2. So we need to find the derivative of this, and this is 1/2 times negative 1/2 times 2 minus x to the negative 1/2. So we have minus 1/2, so plus 1/2 times 2 minus x to the 1/2 to the negative 1/2. So this we can just write this as 1/2 as well. Over the bottom squared, which is simply 2 minus x. So yeah, that was it for that one. Next, we need to find the gradient of the curve at the given point. And the first one we need to do is y is equal to cosine 2x at x is equal to 5 pi over 4. Okay, so first we get the derivative of this, and this is simply equal to negative 2 sine 2x. And so we need to plug in x equals 5 pi over 4. So this is equal to negative 2 sine 5 pi over 4, which is equal to negative 2 times 5 pi over 4 is negative root 2 over 2, I believe. So this is actually equal to the root 2. So the gradient at this point is equal to root 2. This is correct. Oh yeah, because cosine graph, of course. Yeah, so this should be correct. Now on to the next one, where we have y is equal to negative 3x cosine x at x is equal to pi over 2. So we need to find it here. Let's get the derivative of this first, which we can do using product rule. So we have dy over dx is equal to uv prime minus vu prime. So this is equal to the derivative of this times cosine x, so negative 3 cosine x. And then we have plus vu prime. So we have negative sine x times negative 3x, so we have plus 3x sine x. So we need to get it at this part, pi over 2. So the gradient will be equal to negative 3 cosine pi over 2 is equal to 0. So we can simply erase this part, and we're left with 3x times sine pi over 2. Sine pi over 2 is 1. So we have 3x or 3 pi over 2, more or less. So the gradient at that point should be equal to 3 pi over 2. Yeah. Finally, we need to use, it says use technology to find the gradient at the value, but I'm just going to use my brain. So we have first equation is y is equal to sine squared alpha plus cosine squared alpha, which is completely silly at the value alpha. But the thing is, for all values, sine squared plus cosine squared should equal 1. So the line should just equal 1. So it's just a flat line. So the gradient at any point should just equal 0. So dy over dx is equal to 0 for that. So that was pretty easy. And next on to the final one, y is equal to sine p cosine plus sine 2p all over cosine p plus cosine 2p, where we p here. How would we do this one? It looks a bit tricky. I guess we could expand it and factorize. So we have up here we have sine p times 2 times 1 plus 2 cosine p all over cosine p plus cosine squared p 2 cosine squared p minus 1. But this isn't large enough. We can't factorize this bottom part. Okay, so it looks like we have to do it the hard way, which is to just use quotient rule. So first we have vu times cosine 2p, v times u prime. So the derivative of this is equal to cosine p plus 2 cosine 2p minus uv. So we have minus minus. So we actually have plus over here. This is going to be plus sine p plus 2 sine 2p times sine p plus sine 2p all over the bottom squared. So we have over cosine p plus cosine 2p squared. Yeah. And we can probably simplify this. Actually, I'm not going to expand it. I'm going to leave it like this. We could expand it, but that's not really the point of the exercise. So, I think that was all. Yeah, that was all for the speedrun. So I hope to see you in the next one. See you then.